Welcome to aminacademy.com. In chemistry, let us discuss about ideal gas equation and its derivation. The ideal gas law is an equation in thermodynamics and chemistry describing the relationship between the temperature, pressure, and volume of a gas. The ideal gas law equation is equal PV equal to nRT, where P equal to pressure, V equal to volume, and N equal to number of moles of the gas molecules, and R is the universal gas constant, and T is the absolute temperature of the gas. The relation is important here, PV equal to nRT. Practically, there is no such thing as an ideal gas. That means the gases are not perfectly ideal gas. We characterize, that means we assume most probably it is an ideal gas. Exactly, it won't be an ideal gas because it won't 100% obey the gas law. However, in conditions like high temperature and low pressure, where individual particles are moving so fast and are too much away from each other such that their interaction is almost zero, gases behaves like an ideal gas. Then ideal gas law is a useful approximation. Ideal gas law. In thermodynamics and chemistry and physics as well, the ideal gas law is a well-defined approximation of the gases under different conditions. Ideal gas equations like Charles law, Boyle's law, Gay-Lussac's law, and Avogadro law will discuss one by one. Here, first we'll discuss about Charles law. Charles law, sometimes called the law of volumes, gives a detailed account of how gas expands when the temperature increases. We know that if you heat the gas, it will expand the volume. And when there is a drop in temperature, it leads to decrease in the volume of the gases and vice versa. Then we compare a substance under two different conditions with the help of the above statements, that is V1 over V2, that ratio of volume and final condition and volume of initial condition V1 is equal T2 over T1. That means volume is directly proportional to temperature, absolute temperature. Therefore, the relation is V2 by V1. V2 by V1 equal to T2 by T1. V2 over V1 equal T2 over T1. By cross multiplying, we will get V1 T2 equal V2 T1. By cross multiplying, we will get the relation V1 T1 equal V2 T2. The above mentioned equation shows that as the absolute temperature increases, the volume of the gas also increases in the same proportion. Also, Charles law is a special case of the ideal gas law. These laws apply to the ideal gases that are held at constant pressure. When pressure is constant, this relation satisfies. But the volume and temperature go on changing. Boyle's law explains that the pressure exerted by the gas of a particular mass when kept at constant temperature is inversely proportional to the volume occupied by it. For a gas, the relationship between pressure and volume at constant mass and temperature can be expressed mathematically. Here, P is inversely proportional to volume when temperature is constant. When T is constant, where P is the pressure exerted by the gas and V is its volume. This proportionality can be converted into an equation by adding the relations, inverse relation, by using that value K multiplied. That is, P is equal to K into 1 over V. That means PV equal to K. By cross multiplying, it gets PV equal to K, second relation. Here in Charles law, we get the relation uh, V1 T1 equal to V2 T2. Here we have the relations P is equal K into 1 over V. That is P equal to K. By cross multiplying P equal to K. Next, here all this we can write further P1 V1 equal to P2 V2, like it goes. Gay-Lussac's law. Gay-Lussac's law describes that the pressure exerted by a gas of a particular mass when kept at constant volume varies in a direct proportion with the absolute temperature of the gas. In simpler terms, we can say that the pressure exerted by a gas is directly proportional to the temperature of the gas when the volume is constant and the mass is of a fixed quantity. Here, in mathematically, you can say P is proportional to T when volume is constant. It's a Gauss-Lucas law. That is, V proportional to T or P proportional to T or P over T equal to K, where P is the pressure exerted by the gas, T is the absolute temperature of the gas, K is a constant. Now, next, Avogadro law. Avogadro's law, otherwise called Avogadro's guidelines or Avogadro's speculation, states that different gases with equal volumes contain an exact number of molecules when the temperature and pressure is constant. That means we are keeping a container with temperature and pressure constant when the gas is inside. Here, different gases have same number of molecules or molecules when the temperature and pressure is constant. Avogadro's law is related to the ideal gas condition since it has temperature, tension, volume, and measure of a substance of the given gas. A steady tension and temperature. Avogadro's law can be presented by the following equation. V is proportional to N, where N is number of molecules in a particular gas. There is V over N equal to K, where V is the volume of the gas, N denotes the amount of gaseous substances, which is expressed in moles, and K is the constant. When the amount of gas substances is increased, the volume occupied by the gas also just increased. That can be calculated with the help of the following formula. V1 over N1 equal to V2 over N1 equal to K. Now we'll write collectively all the things. First, Charles' law says V1 V2 by V1 equal to T2 by T1. V1 by T1, V1 T1 equal to V2 T2. This is a first Charles law. V1 T2 V2 T1. V1 T2 V2 T1. V1 T2 V2 T1. Next is Boyle's law says P1 V1 equal to P2 V2. P1 V1 equal to P2 V2. Next, Gay-Lussac law. P1 by T1 equal to P2 by T2. P1 by T1 equal to P2 by T2. Then Avogadro law equal V1 by N1 equal V2 by N2. This is Charles' law. This is Boyle's law. This is Gay-Lussac's law, Gay-Lussac. Here Avogadro. Avogadro law. Now we will use these laws and let us derive the ideal gas equation. Let us consider the pressure exerted by the gas is P at some conditions. The volume of gas at that pressure is V. Temperature is at T. The number of moles of a gas is N. Universal gas constant is R. These things we need to derive the ideal gas equation. Avogadro to Boyle's law, at constant N and T, the volume makes an inverse relation with the pressure exerted by the gas. That is, V is proportional to 1 by P. V is inversely proportional to 1 by P is the first equation. Avogadro to Charles. Avogadro and Charles law says when P and N are constant, the volume of gas directly relate to the temperature. V is proportional to T. We have to get it. V is inversely proportional to P and V is directly proportional to T. According to Avogadro's laws, P and T are constant when the volume of gas makes a direct relation with the number of moles of gas. Here, V is proportional to N. R or V, it's easier to remember. V is inversely proportional to P. V is directly proportional to T. V is directly proportional to N. Combining all these three equations we get, that is 1, 2, 3. Here 1 says V is proportional to 1 by P, V is proportional to T, V is proportional to N. Therefore, V is proportional to, first look at here, V is proportional to 1 over P, T, and that is NT. N is directly proportional to V and temperature directly proportional to V and pressure is inversely proportional. So this is the relation. Then by cross multiplying we get Vp is proportional to Nt. Therefore we can write the introducing universal gas constant V. Therefore PV equal nRT, where R is the universal gas constant. This is the universal gas law, ideal gas law. Now this is the relation P equal to nRT, where R is the universal gas constant which has the value of 8.314 joules per mole Kelvin. Now this is useful for calculations. We'll conclude. Any gas is known as an ideal gas when its particles are too far away from each other that they do not exert any force of attraction on each other. In such a gas, the internal energy is in the form of kinetic energy, and any change in internal energy is accompanied by the change of temperature. An ideal gas can be characterized by three states variable: the absolute pressure denoted by P, volume represented by V, and absolute temperature indicated by T. Therefore, ideal gas law is P equal to nRT and equal to N capital NKT, where N is the number of moles, R is universal gas constant, this value 8.314 joules per mole Kelvin, capital N equal number of molecules. Here small n we can keep its number of moles, N is capital N is number of molecules, K is Boltzmann constant, that is 1.38066 into 10 power minus 23 joules per Kelvin. Na is Avogadro number, that is 6.0221 into 10 raised to 23 per mole. So far we discussed about laws of gas laws as well derivation of ideal gas equation. We have done. Please subscribe our YouTube channel.